This conference will
Uh,
now be
Actually,
recorded.
what happens is, while teaching itself, we understand, like, whether it's coming in a right way or not, or if we are missing anything. So probably that's what I felt. But anyhow, you can always ask me if you want to discuss any topic. I am open. If you want to rediscuss, somebody is asking, Sandeep, you are not there in the class yesterday. So that's why, if you are completely present in the class, I will do recap. You you missed the session. Okay. So I'm asking about others. If you are there, then it's fine. I would have done because that quick that is not uploaded in YouTube, YouTube as well. Okay. I didn't do that. I have to do. I thought of making one more, you know, recording and give post it in YouTube. I'll just check the video. If it is fine, okay, I will upload it. Otherwise, I'll record one more time with all that. So now there are a couple of things, on list. Okay, I'll ask you a few questions before moving to the next topic. The questions are like this. So we have seen a couple of things on list yesterday, right? You remember, right? One is appending data. So this is appending, right? Will you agree? What is this? Appending data to a list. We have seen this. One question to all of you is, because these are very important things to understand from the performance, point of view, right? So suppose, right? You just create an empty list like this, somewhere some L1 equal to uh, okay, uh, where some L1 equal to, right, how to create empty list dot. Yesterday we have seen a couple of things, empty of something like int, and then this is one thing. This is an empty list. Now we are adding data. Even if there is data, we don't have an issue. Still we can add append data or prepend data. We can do anything. That is the power of list, right? Internally it uses linked list. It has these things. We can append or we can prepend data to this. That is the advantage with the list. Okay, fine. We'll come to all this. Now, right? I want to append data. How do I do that? L1 equal to L1 plus some 1. So I am just adding 1 to this. If you look at this, then it is giving me, what is this? Found type mismatch, found int of 1, required string. Why it needs strings here? Okay, sorry. We have to use colon plus, right? You remember, right? If it is direct plus, it is thinking concatenation. Usually we use plus to concatenate two strings. If you want to append something, you have to use colon plus. Okay. So this is adding one element to this. This is appending. This is not prepending. Okay. There is a reason why I bought this point here. So we are appending data. Let's test for few more values. Let's add a few more here. Okay. So I am adding 2. I am adding 3, and also what is that? I am adding enough. 4 are enough. 3, even 3 are enough. Okay. Right. So I'm just printing it. Println of L1. Okay. So, and then let's run this. You can see there, it is pretty clear. We are appending data here. This is very clearly showing here 1, 2, 3, 4. Means we are adding something at the end of the list. Okay. Usually this is what happens. But I have a question to all of you now. What is my question is, when list is best fit? Because we had a discussion. When list is best fit, right? When should we use it? When, while appending data or while prepending data? That is my question. We will write here. Okay, that is a good thing, to understand a little deeper into this list thing. So my question is, when list is good? While appending data or while prepending data? That is the question. Okay, the question is this: when a list is best fit? Okay, that is the question. Anybody will answer this question? Okay, right. So now we'll just see here now. Now I am doing appending. Definitely appending is a costly job here. Prepending is not costly. Prepending is the efficient job. But when you do this, this is not that recommended, okay? But you can ask me then what is the other approach if I should add data to the list? Then go for, it's always good if you append data to a list rather than prepend data to a list. Sorry, it's always good if you prepend data to a list rather than appending data to a list. You got my point? Repeating again. When list is best fit? List is best fit when you are prepending. Prepending means adding data to the beginning of the list, not at the end of the list. That is appending. That is where this is best fit here. You got my question right? So now let's see this now. No, how maybe now the question is next question is how to prepend data to a list. That is the question. So this is the what. So when you look at this code here, what I am doing here, I am appending. Will you agree? All of you agree with me or not? Answer, sir. If your answers are, that gives me little motivate, little.
Yes, we are appending.
But this is not recommended, right? Why? From the performance point of view, this is not recommended. Then you ask me, then what should I do? How can I add data? Then you can go for which one? Prepending. How do you prepend data? This, see, simple. If you want to prepend, first let's have a quick idea. We use this operator here. This operator is double colon. Usually this is a scope operator. So we use this to prepend data. To append, we don't use double colon. To append, if you observe carefully, we use colon plus. Just get a clarity here. Observe carefully. If it is appending, apply colon plus. If it is prepending, what is that you should use, sir? What is that you should use here? It is double colon. So that is simple idea here. Got it right? So this is the scenario. But anyhow, you can easily understand. I have a list 1, 2 here, and then that it has reference x1. Now to this list x1, I want to add some data. I am prepending data. You can see here, I am prepending 1 to this x1. Also, I am prepending one more list to this again. Not just an element, but I am prepending a list of elements to the existing list. Okay, let's just quickly test it. So this is one more important thing you have to observe. What is it? This is list is best fit when we go for prepending data rather than appending data. So anyhow, let us quickly test it. If you see this, so what operator you are using here to prepend to add something at the beginning of the list? We use this double colon. Okay, and if you want to append, colon plus. Now let me run this and let us test it quickly. So when you see the first one, this is appending. Second one, you can see 1, 2, that is actual list. Now after that, you can see here we are prepending 1 again, so it's coming first, coming as a first element. After that again, I am adding the whole bunch of list of elements. You can see there. So that list itself is treated as one object here. If you see, this becomes a nested list. Yes, list can have even the whole another list inside that. Not only another list, you can add any other object inside that. That is also possible. Okay? Not just list. Even you can put set inside that. You can put map inside that. That's what collection is. Collection is something which holds other objects inside that. Got it right? Collection is like a cover when you go to this vegetable market. In that you put apple, you can put pomegranate, you can put carrot, you can put beetroot. If you assume every vegetable is one collection, of course you take pomegranate, that's collection of that seeds, or you take some other thing, that is also assumed that as a collection. So that cover itself is a collection. Inside that you can have an object. Again, that object might have some other data. So this is the beautiness how we can store data. Do you get it, sir?
So Manohar, you are saying that adding the data front of the list is easy, then appending the data end of the list, right?
It's not easy. I'm not saying it is easy because it's easy to do in code, either if you add at the end or if you add at the beginning. For us it doesn't have
Okay.
difference. For us we don't have big difference there, because for a developer adding at the end or adding at the beginning is not a problem. But when we talk
Has
from
performance specs?
yes, correct. So when you discuss from performance, when you talk about performance, prepending is best fit here for a list rather than appending. So if you want to
So,
prepare, then list is best fit, okay? Because you don't need to do a lot of shuffling internally if you prepend. But if you append, there will be a lot of shuffling happening internally. That is the difference here. Got it, Bharat?
yeah. So adding in the front is so good in performing wise.
Correct. Exactly.
Okay. Got it. Thank you.
You can also see this point clearly tells that right, in general the proper way to work with a list is to always prepend elements to a list with this double colon or the scope operator like this. This point clearly talks about when how we can work with a list here, okay. Right. I think you are clear, right, Bharat?
It's so clear.
Okay, right. So can you guys please test it, like, how to prepare data to a list? Okay, can you test it once? Okay, let me just please tell this. Take a minute and please test it. Then I will switch to the next topic. Is it done, sir? Testing is completed. Can anybody confirm?
It's done.
Okay, thank you. Okay, before this going to this head or tail or something, one more function here. So far, what functions we have discussed? we didn't start discussing seriously any methods of this interfaces, traversable or filter or sequence or this. We have seen different ways of constructing this list from yesterday's session, and all of you know that. Okay, we can use a tuple, and from tuple we can do a casting. To list means applying a casting, sir. All of you know that. And then this is one, right? One way of creating list. Also, we have seen in the beginning, we can create list with the list constructor, also with the empty method. You remember that yesterday we had a discussion. And also we can apply range for constructing a list with the list of integers here. So now the next method is fill and tabulate. So what fill does? When I say fill for of foo, what this is going to do, sir? This is going to add four elements recursively. Like this foo is added for 4 times. And also we can also choose the range here. Default this will give you 4. 1 comma 4 means what? This will also add for 4, but I have a small dot one. Let me quickly check. Maybe we can add after this. So we have already x1 there. That's why it's showing an error. We don't have a big problem here. Nothing to worry. I'll take xx1 and then xx2. Okay. Now let me run it.
I think if you change that order, right, it will be more meaningful, I think.
Okay, see the difference here. Which order, Madhu?
That you told me, right? You told us, right? If you prepend data to the list, so then the performance will be improved. But here
Correct.
the list is x1. But if you add to that x1 list, then it will be more meaningful. But we are assigning to x2.
Correct. I understand. But this is the only way what we have here. Okay. When you are doing this, what we are doing here, finally we are adding the data to which one here? 1 minute. Of course, we are altogether we are constructing a new object. That's what you are saying.
Yes. Then
So
if you try to change that value val to var,
okay, got
then
it.
it allows us. Yeah.
Yes, that is also another important. Maybe I can take that. So you are saying that might be, why don't we
X1
take? Of
exactly.
course.
Yeah.
Okay, that's good. 1 minute. But when you do this,
Here x1 that println that the above one.
no, that is fine. 1 minute. Okay. Okay. And what is the issue here? This is fine. When you add this thing here, type mismatch found list of int required int. Okay, got it. In this case, what is that is it is expecting just not a list but simply an integer here, because when we constructed here the constructed list, this becomes what the type becomes list of int. So again inside that you are trying to put heterogeneous elements. So that's why I cannot do this. What is this list of 1, 2, 3? Why? Because this list accepts whatever the x1. By default, it is created as list of int here. So this accepts all integer elements to be prepended. Now I am not prepending integer elements. Of course, I am doing that with the list object. Now this becomes what list here, and the type of this is not a list of list, but it is a list of int here, or this is not list of any otherwise. So that's why it is showing an error, because that's what we have constructed in the beginning here. And when you keep appending or prepending elements, what happens is it is going to expect the integers as integers to be prepending here. Okay, so that's why we got an error here. So I'm removing this. Do you understand the discussion, right? So why we got that? Now this makes more sense, as Madhu said. So here we are prepending data and we are assigning to the same object instead of assigning to different objects here. Yeah, that's fine, Madhu. That is also a good thing to add here. And fine, but you got clarity, right? How to prepend or how to append. Thanks for bringing that point here, Madhu. And now when you run it, we get the same output. But the difference is when you apply fill of 4, this is what I'm trying to discuss actually. But we were again we were again we just gone back to the previous discussion there. But anyhow, it's a good thing because there is some kind of third variables using here to initialize this results. So, but now we are preparing all that data to the same variable. So that is also a good thing to observe here. You can see still the data is getting prepended. You can see that when you look at the output, you don't have a problem there. And now coming to the difference between fill of 4 and fill of 1 comma 4. When you apply fill of 4, it is adding 4 foo objects or 4 foo strings to this list actually. And if you say 1 comma 4, internally what is that it is doing is it is trying to take a list, and in that list it is trying to add this foo, it's like implementing some range function internally, and the range is 1 comma 1 2 3 and 4 here. So what it is doing is it is adding those foo elements to the list, and if you look at the output here, it's not directly adding. Second time, when you have a range, it is taking what, sir? It is internally applying what is it applying? It is applying using a list object. First it is appending data to the list, or prepending. It is some kind of thing, we don't need to worry about it. It is adding the data to the list, and that list is again returned by the fill function here. Got it right? And that is stored into the list again. So got it right? You understand this, or any questions on this? Okay, right. Now next one. Is that good for all of you? That is what fill is doing here. Understood? Now tabulate. So to create a list, this is another way of creating and populating data to a list actually. Just now you understood fill. Now let's talk about tabulate. So what tabulate? Tabulate is similar to fill, but the difference is I am seeing we are applying some business logic here, and also we are applying a lambda function here to apply with tabulate. Let us just try to run it quickly. So now what tablet does here? It's simple. We are trying to get n, and we are applying a business logic on this. Probably it is going to take 4. I am expecting it takes starting from 0 to 4. I hope the difference is by default it will take the indexing from it's like a range function. It takes from 0 to 4. 0 to 4 instance, 4 should be exclusive. It will take 0 to 3. First time it should be 0, that is applicable on that, and 1, and then 2, and then 3. Let me just run it and see the output there. Correct. You can see there, right? Initially, what this is doing internally, let me just show you the algorithm behavior internally for this. Fill by default gives you the number of times. Suppose you say fill of 4, it will fill that for 4 times. Means this is recursively added to this fill, list when you apply fill. But when you apply tablet, what is going to do is it will give how many it gives a range of values starting from 0 by default. range of values starting from 0 that I am passing to the lambda function besides that, which is passed as a parameter to this tablet. Initially, the values it produces, it starts from 0. So when you pass it to the 0, n is 0, 0 into 0, it becomes 0. Again, it becomes 1. And 1 into 1 is 1. Again, it becomes 2. 2 into 2 is 4. Again, it becomes 3. 3 into 3 is 9. And 4 is exclusive here. It doesn't take 4. What's happening here is it takes to 0 to 3. And then 4, when you talk about 4, 4 is exclusive. Exclusive means it is excluded. It's like until, you remember until, right? Something like that. Right, to n until will exclude the last n value. Same thing here also. Okay, so 4 is excluded. Now that is the reason you can see there. Now we don't get 4 4 16, you cannot see there because it's not taking 4 here. You got it right? All of you are clear, sir? Okay, that is one more analysis on tablet. Now you got the difference between tablet and fill. Both are doing, what is that, constructing a list and filling data or populating data. But the difference is fill by default fill n times. If you say n, that many times it will fill the data. And if you pass any range like 1 comma 4, what it will do? It will try to add that whatever the element you are passing to a list, and then that is again passed, appended to the actual one here. And third one is tablet is again similar to fill. The difference is it produces range of values starting from 0, and that we can apply some kind of functionality. And finally, the last one is this is a little more interesting actually, because while I was trying to test all this, not now, some time back, like 6 months back or more than that. So I tried to understand every time what's happening in the background, what this is doing, the algorithm is doing there. Just anyhow you understand this, where this is again a lambda function here, which we are passing. All of you know pretty well about that. It's a lambda function, and we are passing 2 parameters. And we are doing product of AB. Every time we get A and B values, and from that AB values we are doing a product of AB here. If you observe carefully, it's more like doing a Cartesian product. It's clearly stated in the comment here if you observe there. So what is happening here, how this is going to work? Suppose if you don't have this analysis which we have here, if I just copy this, okay, and if I just paste here, and if I just run this, okay, leave about the first all other things there. If I just run this, then you get an output like this. You have almost right, how many lists are there? When you look at it, you have 0 1 2 3 lists will be there. How many lists, sir? If you look at the output, you get 3 lists, because here we have 2 parameters in this tablet. What is it? The first one talks about number of right, this gives the range, first parameter, and 5 is what is it doing here? It is trying to give us again range of elements. This is also giving range of elements, but number of rows is decided by the first element, number of columns is decided by the second element. It's more or less like constructing a matrix here, a matrices of elements here. Okay, this also starts from 0 to 4. Okay, it starts with 0, ends with 4. This starts with 0, ends with 2. What is that? The third one. So when you talk from here, it gives range of values 0 to 2. It gives range of values 0 to 4. That we are doing a product here. If you look at this analysis part here, what is that? This is how it behaves. We get 3 lists and 5 elements each. And that 3 lists are created, populated with data like this. A is what is it, sir? A is starting with 0. And then here, if you see again, B also starts with 0. Like, if you look at it, but once A will be stable, but B keeps changing here. If you see here, the value, the first element here is always everywhere 0, but the second element, the call value, if you see the second part, it's giving the range of elements from 0 to 4. Means what? The second, B keep on iterating from 0 to 4, whereas A will be stable throughout this iteration until it iterates for 5 times. Again, if you look at the second iteration, A is 1 here, and then what's B is doing again, A will be 1 time here, it will produce 1, and B will be iterating from 0 to 4, and we are doing a product of that, okay, because it is A into B. Again, A is 2 and B is 5. Again, we are doing, product of 2 into, again, the range of values that is produced by B0 to 4. So that's why you have 3 lists, and those lists have output like this. If you look at it here also, I had copied and pasted. Now, first time it's all zeros. Second time it's 0, 1, 2, 3, 4. And third time we got 0, 2, 4, 6, 8. We got multiples of 1 in the second list, multiples of 2 in the second list. It's all because, because of the algorithm which is applied here. Are you following, sir? Is that clear now? Suppose some of you might understand this, some of you don't understand if this analysis is not there. Okay, right. I don't say it's not difficult, but it depends like how we analyze it. That is the point here. Okay, is that good for you, all of you, right, sir? Is that clear now? So please test it once. There are other examples as well with tablet with one parameter, and you can see this is actually a lambda function with parameters. Lambda function with this is also important, sir. We have done this while doing functions. Underscore acts as a placeholder, right? You remember, right? You remember this? We use number of times in this Spark applications. This underscores things, underscore plus and underscore into underscore. You see a lot of times when you are working with Spark. This is also very important here. Okay, so even the third one, we have just seen a scenario. This business logic you can implement as you like, sir. It's not like we should have a proper we should have a fixed business logic. It changes from requirement to requirement, but tablet becomes handy when you are trying to produce values like this, like by passing these parameters. Okay, so you can test this also as well if you are interested. You can try this. This is giving squares of numbers. This is giving multiples of multiplication of numbers, and this is giving again squares. Okay, and then also it is doing some subtraction there, like that. Would you like to test it? Maybe you can test it, sir. These are all different simple and useful scenarios which we can work with this tablet method. Now we have seen fill and we have seen tablet. We have seen how to append data to a list. We have seen how to prepend data to a list. Okay, we are slowly adding things to the list now. Maybe this is an error, getting error because it's a repetitive one. So we can just test it quickly. Okay, squares, printing squares, printing mul, printing the third one is squares too. Okay, let's just see. I think right now you analyze the output, sir. All of you can analyze it. It's not something difficult this time for all of us. Okay, because you know it. The algorithm, we had a clear analysis. Anybody has any confusion on this algorithm? Anybody has any confusion, or all of you are good, sir? Please say yes or no, sir. Is that clear, or any confusion on this? Nobody is answering, sir. Can I have any yes or no from you, sir? Okay, Srikanth wants me to repeat once, sir. You do one thing, Srikanth. I think I know, right? Sometimes initially, even when I just ran it, not now, in the beginning, even I got a little confusion there. So what I have done is I have just done a tracing of that. That's why in the document also you can see my tracing. I just try to do it because first to understand myself what's happening here, Srikanth. See, you can pass, two parameters as well to tablet. And here, the first parameter tells number of lists you are going to create. The second parameter is about producing it will produce range of values. Of course, the first parameter also produces range of values, but the difference is when this iterates for one time, this iterates for 5 times. That is the meaning of that. It's more or like a nested loop, Srikanth, right? A loop in the side loop. Like for I equal to 0, I equal to 1. Yes, I equal to 0, I less than 3, I plus plus. This is like I equal to 0, I less than or equal to, again inside that one more for loop. Okay, I less than 5, I plus plus, something like that. Now you get an idea, right? How it works. If this iterates for one time, this iterates for 5 times. That is the process here. And that those parameters are passed to this parameter list of lambda function. You know the syntax of lambda function in Scala, right? It takes a list of parameters and they are passed to this business logic or expression. Okay, so it will extract the first a from this first parameter and b from second parameter, and those are passed to this business logic, and a product is applied on that, and it is clearly stating that it's a kind of Cartesian product we are applying here. You remember Cartesian product from school days, right, Srikanth? So that's what happens here. Now, if you look at the analysis here, the first thing, number of lists we are going to get created depends on the first parameter. Suppose if I put tablet of 4, 5, then I'm going to have what? 4 lists with the each list having how many parameters? Probably 5 parameters. Okay, or 5 elements, and it's a product of this. You can change business logic. If you don't want product, you can put plus, or you can put some other business logic, whatever you need here. This is just only for understanding like the behavior of tablet here. That's all. Okay, now if you see for the first time, this iterates from 0 to 3, means it will take up to 2. This iterates from 0 to 4. So what happens here? So A is 0 and B is 5. Now this is the analysis. A will be stable throughout this, and B keeps on, keeps on iterating. Initially B is 0, B is 1, B is 2, B is 3, B is 4. Likewise, what happens, Srikanth? The product of A and B is done, and all, of course, as you are doing, product of zeros, you get, when you add something to 0, it's all 0. That's what you get here. Again, second time A is incremented to 1, and then B becomes again same 5. And what happens? It's more or less, we are trying to find multiples of 1 here. That time A becomes 2 and B is 5, and this iterates from 5 times, 0 to through 4, and still that A is stable here because no, that's what A is. But B keeps changing here, and we get multiples of 2 here. Okay, the first one obviously becomes 0, and rest of that looks good there. Is that clear to you, Srikanth? Is that clear? Okay, thank you. Right. So, okay, fine. Let's move to the next one. Let's have other functional methods that walk the entire list from beginning to end, such as filter, map. We are going to work with them a little after this. When you go little bottom of this notepad, they are there. These are there are a couple of things. There are a few important points you need to observe carefully. One is what is that? This you see this, right? Double colon, which is a scope operator. Right? We just now we had a discussion on this. The purpose of this is to prepend elements to a list. Head and tail, these are also very useful methods. When you talk about head, it will return the head element. When you talk about tail, it returns the tail element, last element. Head means first element, tail means last element. Probably these are very useful operations which we perform on list here. Okay, just make a note of that. Okay, or just focus more on that these things. Okay. So these are what they were saying is probably other methods you can use on list that may be slow because list is immutable. That is one more thing, correct. So and you can't add elements to an existing list. The way you work with the list is to modify elements it contains as you assign the results to a new list. That is also important point. So point is whenever when you are trying to add elements at the end or in the middle or somewhere else except in the beginning, definitely as it is immutable, it tries to create a new object internally. The concept of immutability. I have explained that in string topic. So whenever you try to modify this immutable list, what happens is internally a new object is created and the address of that is copied to the reference, right? So it doesn't modify the old object. Every time you add something, a new object is created. So in that way, what happens is other than this, right, prepending, other operations definitely they were slow, no doubt about that. And this is an idea. So next one.
Manohar, sorry to interrupt.
No
You
issue.
just said head and tail. Head means returning the first object and tail means returning the last object, right?
Last object, correct. Correct.
But when I just executed that one, it's returning the entire list,
Which
not
one,
the
head?
last tail.
Okay. Let me just test it once, Bharat.
Uh, can we go with the squares option?
Yeah, sure. We will try that. Okay. Probably otherwise the anyhow. Let me test it and conclude it. Squares dot head. Okay. Okay. Squares dot child. Okay. Let me run this. Hmm.
It's returning the entire list, not the tail of.
1 minute.
Head is working perfect.
So head is working fine. 1 minute. What about tail? Let me add a text. Okay, leave it like that. Let's run this. So head is returning 0.
Right, it's working perfect.
And tail is giving us the all the elements.
Right.
1 minute. 1 minute. Uh, where is the squares for us? I will also just add this so that first let's see the data, then we can conclude. Okay, squares means you can see this is what happening here, Bharat. Head means it is taking the first element from the list. Can you see there, Bharat?
Yes, yes.
So that is perfect. Okay. Tail means excluding first element, it is taking remaining all elements. Last, that's it.
Okay, okay.
Okay, that's what the algorithm is doing.
Okay, got it.
You got it right?
Yeah, it's clear now.
So that is the difference. Except the first, rest of the elements are treated as tail elements. So it is returning all those elements, Bharat. Clear?
Yeah, it's clear. Thank you.
Actually, we might be expecting 25. Even you might be expecting 25. But
Yes, yes.
this is little surprise for us because we are seeing all the remaining elements except the first element. So the algorithm behavior is simple here. It is treating the starting element as the head element and rest of the elements as tail elements. That's what it is doing. Okay. Anyhow, if anything is there, we can also do the workaround on that, Bharat. No issues. If you come across any such things, okay?
Sure.
Okay, right. So now, let us see this. These are important operators here. Colon plus. What is this for, sir? Can you see? Now we have few more operators here apart from colon plus and colon colon. Colon plus is appending one item. Okay, old list plus something. Plus plus is appending a list to appending n items, means adding one list to another list. Plus colon is prepending. Also, you can also use colon colon also prepending. Plus colon is for prepending. And plus plus colon means prepend n elements, n items to a new list. Sorry, prepend n items. So it's easy to understand if you see there. Depends on this colon, presence of colon. If it is coming before you are appending, or depending on presence of plus otherwise. If plus comes at the end, it is appending. If plus comes at the beginning, it is a prepending. And plus plus is adding n elements to the new to the existing one. And again, plus plus colon means it's nothing but what prepending. Default plus plus is a new list to existing list. Plus plus colon is prepending a new list to existing list. That is the simple analysis. Okay. Now there are few examples here to test it. So you can also test yourself, sir. But before that, did you guys tested these things? All of you tested this, sir? Please, can anybody confirm yes or no?
Yeah, we done.
What about others, sir? Are you there, sir? Or are you following, all of you? Madhu, Sandeep, Srikant, Sudarshan, Suresh, Deepak. All of you are good, sir. Harish. And Veera Prasad. Okay. Right now.
Manohar, can you just show to that methods and description one more time, please?
Sure, definitely. Yeah. Any questions
Plus
here?
plus column. Yeah, I just want to understand that plus plus column. Fine. I don't know. I got it.
No issues, sir. You can test it here, sir. Okay. The easiest thing to remember is if plus comes after, you know, if it is at the end, means you are appending. If it is at the beginning, it is prepending. The easiest thing.
This part can you copy and paste?
Sure. Now you can test all that. Do you understand these things, sir? All of you? How which operator is used for appending, which is used for prepending, which is used for appending a new list to old list, which is used for prepending a new list to you know, old list. Is that clear, right? Okay, next. See this. We have a list here. So this what we are doing, sir? We are appending an element here. You can see there. For that colon plus. And we are appending a new list to old list. This is appending because plus plus. Now we are prepending an element to the existing list. Now here also, what this is doing, this is, what is this, sir? Plus colon means it is prepending a new list to existing list. This is prepending. Plus colon means appending. We should check this whether this will work or not, but we'll see. X1 is having two elements, no issues, sir. The last one is prepending again a new list to existing list. Prepending means something comes to, you know, at the beginning. Appending means something comes at the end. We can just quickly test it and observe this, sir. Okay. Now val x11, then just x11, x222. You can also test parallelly, so please keep testing. And then x5511, x66, x11, x33. Okay, and then 66. So this is simple. We're just testing this appending and prepending of elements here. Okay, right. Shall I run it? All of you are clear with this operators, right? Let me just quickly run this. You know, you have to analyze from here. This is the actual list, and then we have appended data. 3 is added at the end for second time here, and then we have again x22 is prepending the whole list to this existing one. So definitely you can see that the prepending of data. What is this? 1 minute. We have 0, 1, 4, 1, 2, 3. X22 means yeah, no issues, sir. Where the 0 is coming? 1 minute. X11, 1, 2, okay. X22, this is also fine. X33, 0, 1, 4, 9. Okay. I am printing wrong. You can see there I am printing X3. It should be X33. That's why I am seeing something else. So X3, now you think we get expected out. Now this is, now you can see there 1, 2, 3, 4, 5, 6. Fine. Next one X44. Yes, we are prepending 0 to the previous X33. It starts with 0. This is also fine. Then again after that, if you look at this here, there is a difference here. See, right? Can you see here, sir? You can also observe one more important thing. When I say plus colon, this is a prepending, but this is used to prepend one element at a time. If you see, observe carefully, observe this difference, x55 and x66. You get a clear difference. Usually, if you want to combine data without adding it as an object, you should apply plus plus. If you apply plus plus, it will completely mix that merge. Actually, it will merge the elements of one list with another list. Suppose if you see x55, I am saying x11 plus colon. Plus colon is used to prepend one element at a time to an existing list. Now here x11 is a list itself. If you see there, observe carefully. Now I am trying to add it to x33. Now what's happening here? The data is not going to be merged here because the operator which we choose is not plus plus colon, but it is just plus colon. You can see that list is added as a list itself. That it completely added as a list object, but it's not merging the data of this list with the other existing list. Can you see that? Suppose if you see x66, when I said plus plus colon, the same operation which we have done at x55, when you are doing with plus plus colon, you see it is merging that data completely. It's like more or less doing a flattening, what we call. It is flattening list and merging that data into the existing one. And it is becoming whole new list with the data from both lists merged, and finally that is initialized to x66. Do you understand this, sir? That's what happening here. Got it right? That is also very important to understand. Even you can do the same thing. If I say here x11 plus colon, again if I say something like some other list of 4, 5, 6. That list is added as as a single element. It is not going to merge that data from the list to x1. It doesn't happen. Got it right? All of you are clear, sir? This is an important observation you have to do. Okay. So, can you please test it, sir? Yeah. Can you test it now? If it is done, then just confirm, sir. If you finish testing, please confirm. Otherwise, take 2 minutes and please test it.
Manohar, Bharat here.
Yes, Bharat.
See, every time we are assigning the to list or list plus item to a variable and printing that variable, right? As of
Correct.
now,
Correct.
if we print, assume println, I want to write a string appending to list and close the double quotes plus x11 plus colon x22. Then I'm getting a different answer. Can you just try with that?
Sure. Can you just type that in the chat box, whatever the requirement you have, Bharat? Please
Actually,
do.
I'm trying. I'm looking from mob. It's a bit
Looking
hard,
from?
but I'll try. I'm going through the video from my mobile.
Oh, okay, okay, it's in mobile. Okay, okay, you can tell me. I will print it here. Please tell me what
Println
println,
double quotes.
double
Write some
quotes.
hello hi something
Okay, I.
plus
Okay,
x11 plus
x11.
colon x44.
Okay, okay, you are saying this, right?
Yes, yes, yes.
So you are getting an error, right?
No, I'm not getting an error exactly. Um,
Mm-hmm.
I'm getting high repeated.
Okay, I understand, but here if I do this, I'm seeing an error. You didn't get that,
No, I haven't got any error.
but actually, right? In a print statement,
Actually, I used the earlier x1, x1, x2, which we use for x1 dot fill hello, x2 dot list dot fill 4 comma 2 hi. I just used those examples. I haven't taken these examples. I haven't used the previous examples and working on.
okay,
Uh,
because in this print statement, we
mhm.
can apply plus operator as a concatenation. Now, if you
Right.
bring in the other thing, it's syntactically it is invalid here. That's why we are getting an error. Bharat, okay,
Okay. Can you write x11 and x33
x11. Okay,
colon plus?
we cannot apply colon plus here. It leads to error again, Bharat. We should use plus
Okay.
as a concatenation. We are using print. The behavior of print is it expects plus to concatenate things. Otherwise, it will perform addition.
Mhm.
It won't accept other operators inside that. That is the how print function is created. It is designed like that, Bharat.
Okay.
Got it right? We cannot do
Okay.
whatever we want it in print because the operators allowed in print are right. Directly we can apply plus. That's all. That is also overloaded here. Either we can use it for concatenation or you can we use it for addition of two integer like numerical values. Suppose if you want to do anything else, put a bracket. Put a bracket. Now you add something. What do you want me to do?
Uh, can you just write with the hi plus squares plus x2?
I plus squares. Huh?
I plus squares
Hmm.
colon plus some number colon plus.
Colon plus you cannot direct. Okay, we have to use a bracket here. Even then, it is not allowing us. Okay, so that is not allowed in print, Bharat.
But actually it's showing to me and I'm getting like a vector open parenthesis h comma e comma l. I just written hello and x3 and 216. So I'm getting vector h comma e comma l comma o and l list. Again the list is bifurcated has comma list l comma I comma s comma t comma and the values.
Okay, fine. But Here, when you try to append internally directly like this, okay,
Can you write
it's
colon plus, not plus colon,
okay. You want me go for colon plus?
not
Okay,
semicolon?
correct, correct. For appending, I put plus colon. Okay, that is not valid actually. So what we do is colon plus. Alright. Okay, fine.
Can you remove the brackets square bit before square and after? Oh, it's throwing an error. Okay. Just
No,
try this one.
this time it is concatenating actually, no issues. Let
Can you
us
run it?
just try. Yeah.
See.
Okay. So what's happening here is there is a concept like string plus anything is a string. Bharat. And what,
Yeah. Sorry, I went on mute. I went on mute. Go ahead.
so if I am not wrong, what's happening here is when you do this, just taking a vector, I so this whole thing is treated as one value.
I
Bharat.
plus squares. I plus squares
This
is treated as one value.
one value, and that whole value is appended to a vector here.
Okay.
Right? In that every character is treated as one value here. Every character.
Mm-hmm.
That's what happening here. If you see there, giving us a because the reason should be default. This might be in what should be the type. Let me check the type of squares first thing. It is giving list. So when you try to append multiple values, the behavior. Okay, let me try what this is giving us. This is also listed. Okay, 1 minute. Let us assign to some variable here, Bharat, so that gives more analysis here. Now put your cursor here on this. Okay. So by default, what's happening is when you do this, when you are adding a string to this, suppose you remove this string, Bharat. The same thing like
Hmm.
the casting principles. Yesterday we have discussed. Remember, right? Now
Yes,
squares
yes.
is right integers, and you are appending something to that. Okay, no issues. It's a list. You are adding list with list of integers. So that you are appending an integer. We don't have an issue, Bharat. So
Right.
as soon as you append high to this, it becomes what? Now the total casting concept changed here. This whole
Mm-hmm.
is converted to what is that? An indexed sequence now. This list plus string became indexed sequence. Right?
Okay.
String, an implementation class of string is an implementation class of indexed sequence. Should I go back to the hierarchy and show you?
No need. I remember that one, but just I
Yes.
want to get confirm this one.
Correct. So what's happening internally is if you look at the maybe for for others to get a clarity. So this is what happening here. Scala collection hierarchy. When you look at it, it is an IMPL class of right. When you look at this here, let us just have a quick analysis on this. Can you see here? Okay, look at this. Here, string is an implementation class of index sequence. When you are trying to add that to the linear sequence, it is getting converted to indexed sequence, and internally by default, it is using implementation class as vector. That internally uses this one. Now, string plus list, it is converting into vector, and every letter in that string is added as one value into vector, one element into vector. That's what happened here, Bharat. You got the point?
Got it, Manohar. Yeah, got it. Now I got it.
Yes.
With your clear presentation, I got clear understand.
Thank you. Thank you. Okay. Right. So that is why, right, so much of, that's all again internal algorithm. So when you see the magic is, it's like, when you add that string to this list, suddenly there is something else coming here. So the analysis is how this casting is happening. Again, you should look at the hierarchy and we should resolve it. That's all. Got it? So, right. It's a good thing to, we understood one more new thing here. Okay. So that's all, sir. This is idea about it. So whenever you have a doubt like this, first you initialize that to this variable set, some variable, then you get an idea what is the type it is returning, and based on that you can understand more of that. Okay, you got it right. So
Yeah, Mana, sure.
is that clear to all of you, sir? Is it good? Anybody has any questions? Tomorrow we are going to work with much more interesting functions, so this is going to give us, so these functions definitely gives more insight into this list class. And also these are very important for us. Anyhow, we keep doing these examples, whatever we have, definitely going to give us a clear picture. But for one time, we can't remember. We need to keep practicing because there are loads of methods here. To remember all these loads of methods, right? You need a great practice. Okay, don't worry. I don't see even people asking too many questions on Scala. Got it right? So it's not legacy like in Java. Vector, this Scala is a totally different thing. Srikant, okay? We don't have the concept of deprecated things here, like legacy characters. It's not mentioned here, okay? Because it was just newly introduced Scala. That concept of legacy was not still no, it was not still introduced. So any questions, sir? All of you are good? Any questions? So this is for today. Tomorrow we do more. Thanks for the questions in the middle. Those are also adding some more information to the session. Any questions, sir? Okay, thank you, folks. We'll meet again in tomorrow's session. Right.